So let's start with this bag right here. We'll take this down. Let's open it up and see what's inside. Now what's great about this system is everything is in a nice carrying case that won't get lost. And everything that you'll need for calibration is right at hand. So we have another bag of goodies right here. Go over that shortly. Another box of goodies. And the heart of the system, the actual 3-in-1 stand itself. Let's talk about this for a second. This is the 3-in-1 stand. What does 3-in-1 mean? 3-in-1 generally means that most of your ADAS calibrations are done by one of three ways. Either a trihedral cone, a flat plate, or a Doppler type setup, which we'll all get to in this bag. Now, for the OEs, their answer was always 3 different types of stands for every different type of car. And a lot of even the aftermarket companies, the stands were all clunky. They didn't last very well. This is a nice, robust stand that can mount everything and put it in one convenient location. So we'll put this off to the side over here. And we're going to open up this bag right here. We have, this is the Doppler generator for doing blind spots. You'll see this used in Volkswagen and Audi, Porsche, and some Mazdas will require this to do the blind spot calibrations. The charging brick for the blind spot. You'll also have this mounting plate. This mounting plate will adapt the flat plate, which we'll bring out later, and the Doppler generator. The way this works is we'll put the mounting plate right here, and then the next component will go onto it. Just like this, and now everything is standard. Now, say we have to do a front radar calibration. For many of the radars that are on vehicles, you'll use a trihedral like this. And this mounts easily. Taking this off, put this away over here. And this trihedral mounts nicely, right, to here. Now this does most of your front radar calibrations. Toyotas, Hondas, a lot of Mazdas will do this. This is a lot of the front radar calibrations and blind spot calibrations. Toyota blind spots are famous for these. Some Mazdas will use this as well. So on this, you'll see, you'll have a bubble level for up and down and side to side, so you can make sure that your radar is straight. Put this back on. And you also have 3 adjustable feet, which is really great for most shops out there, because not every location that you have will be perfectly flat, and you'll be able to adjust within reason to make sure that this is pointed level and flat with the car. What's also good about this is you have the measurements all the way up and down in metric, and these are calibrated to the ground. So when in your service information it tells you to put the radar or blind spot to a certain height, all you have to do is follow the line up, and then move it up and down. Lock it down, and then you're good to go. Another cool thing that this setup does have is a laser right here that you turn on and points. That points to the radar itself, which is really great for making sure that you're lined up. In this bag, you'll find all kinds of good stuff. You'll find the flat plate I was talking about right here. This flat plate, you'll see this used on Nissan vehicles. Some newer Toyota and Lexus have an option to use this. Volkswagen and Audi and Porsche all will use a flat plate style for the radar calibrations, the front radar. You also have plumb bob from that finding center of the vehicle, and a metric tape measure. All ADAS calibrations are done in metric, and all the specs are in metric. And it is important to have a metric tape measure, which you have right here. You also have this little box right here. Inside this box, you'll see your 5-way cross laser. I call it R2D2 because it looks like R2D2. You'll see some glasses for filtering out laser, a charging cable. Most importantly, this 5-way laser here. What makes this system great is most radar calibrations are set to the center of the vehicle, or all radar calibrations are set off the center line of the vehicle. And a lot of manufacturers, they specify different ways of finding center. What this will do is you'll mark your center with your plumb bob from your emblem. You'll drop your center, and you'll drop it on these included little cookies here, which are right here. These included little reflective targets. You'll drop your plumb bob on your reflective target, face the center, so now you'll know what center is on the vehicle. And then this little guy is a 5-way laser. You put that over your center line, turn it on, and it'll shoot a laser down onto your target. It'll also shoot a laser across the vehicle here. And then if you press the V button that's on top here, it'll shoot it straight back. If you press it again, it'll shoot along the side. That's what this guy is, R2D2. In this kit, you'll also see a hex turning wrench for adjusting mostly Honda front radars or a live adjustment. And you'll do that with this. You have a laser reflector. What this does is you'll put this in the front or the rear of the vehicle on your center line. You'll use your R2D2 or your cross laser here and shine a laser right through this. It'll light up, and then you'll hit your V button. It'll shoot a laser all the way back. We'll go over that a little bit later. And that is the easiest and quickest way to verify you have found the center of your vehicle. Because you're using a laser, it goes on forever, and you can take all of your measurements from there. It's a really great setup. And for those of us with bad knees, you have this little mirror right here. This little mirror's job, you put it down, and you'll be able to look underneath the vehicle at this reflector. When you turn the laser, you'll see when it hits this reflector, all without getting on your belly. What I would like to do now is show you how the flat plate will mount to the 3-in-1 stand. So you have your 3-in-1 stand here. What you'll do is take your adjuster plate, mount it to the stand. And what I like to do is put this a little closer to the ground. Put on your 3-in-1 plate. And on this 3-in-1 plate, like the trihedral, it has bubble levels to make sure that everything is level. So again, because this is kind of heavy, I always like to adjust it down low, make sure my 3-in-1 stand is perfectly level, and then I will raise it. I'll take this off because again, it's a little heavy, and then I will then raise it to the height that the service information or the tool requires me to. You'll then mount the stand, and you're ready to calibrate. Oh, and there's one more thing I would like to show you that only Matco has right now. For those of you who have done blind spot calibrations in the past, especially Toyota and Lexus, I'm looking at you. In their service information, they give you the target placement and the measurements in degrees from the back of the car. And what you'd have to do is measure down, pull a string put an angle finder on the string, and measure across a certain angle until it reaches a certain point, and then drop your target right there. It can be kind of difficult to do. What Launch and Matco have come up with is this protractor right here. What this protractor does is pretty ingenious. Again, you use your laser 5-way laser to mark the center of the vehicle. And again, you'll see that you have your angles from center, which will match up with surface information. You then place the protractor down along the center line that it shines. Once that's there, you know that's good. The surface information will tell you what the angle should be from center. All you would need to do is turn the laser on and turn it to the degrees it tells you to do. Let's say it's 53 degrees. Measure down 53 degrees and follow with your tape measure to the end, and then place your target. It's really simple. This is really ingenious that they came up with this. Here's this next box that only Matco has at the moment, and I'm really excited about this. In this box, you'll have a digital angle finder. What you also have is a suction cup for front radars. You'll see this as a necessary tool on a lot of Jeeps and Hondas for doing a pre-adjustment. What you would do is you would stick this suction cup to the front of the radar, and then you put your angle finder right on here, and then you do a pre-adjustment to level or whatever the surface information tells you to do. This is great. What's also great about this is there are multiple manufacturers that use something just like this, and they include all the cups you'll need for those manufacturers instead of buying multiple tools. Really awesome. Another cool thing that's in this kit, for any of you who have dealt with any front collision cars, this tool right here will clip directly on to a flat style front radar. Now this is important for any of us who have done any collision repair vehicles. A lot of the times a radar has to be perpendicular, straight up and down, pointing straight to the front of the car. And a lot of the times these cars take a hit, the radar brackets get bent, and the car will fail calibration, and you don't know why. What this does is once you get the radar exposed, you clip this to the radar itself, put on your angle finder, and then you'll know how far the bracket is off. Sometimes it's just a little tweak. Sometimes you'll just have to adjust some screws. What this is a good visual indicator to you and to your customer, if you're doing work for a body shop or doing work for yourself, that a bracket or something is bent. You also have this little guy right here. What this is this is a parking sensor calibration tool. What do I mean by that? For newer Lexus and Toyota vehicles, anytime you disconnect the bumper or a parking sensor, you'll get a light that you can't turn out. And what actually needs to happen is you need to calibrate those parking sensors. And the Toyota special tool looks something like this, has a tiny little stand that mounts to the face of the parking sensor. And then you put an angle finder on that face and you measure the angle. You put that angle into the scan tool and it tells you how to, and it calibrates the car. What this does is it goes onto the sensor, and also the Toyota tool is just a piece of metal that can easily scratch a sensor. This is a nice scratch resistant coating. You put your digital angle finder on there, mount it to the sensor, and you can record your measurement and put that into the scan tool. That's all in this kit. And in this kit you also have another Honda adjustment wrench. So we have seen everything that was in the 3-in-1 kit. Let's put it to use. What we're going to do today is a front distance sensor calibration on a 2023 Audi SQ5. What makes Audi different than many manufacturers is they put 2 distance sensors in the front of their vehicles. You'll see one right here where a fog light would normally be on this side, and the other one will be a matching pair on the other side right here. To do this calibration, you're going to be using the flat plate on the 3-in-1 stand. And what's great about this is you can use all of the instructions that will be included in your scan tool, or you can use the OE instructions if you would like. Because everything that Matco does is factory sized, you can use all factory measurements. You can even use a factory scan tool if you want to get this done, because everything is just like factory. All right, so let's get started. Here we are with our Maximus 5.0, and I have done a health check on the vehicle. I see there are no real codes. There are some codes in the gateway here, those we have here. Control module for emergency cell communication, Ethernet module. This car was at a body shop. This is nothing we're concerned about for the ADAS calibration, but it's here. So to do this distance sensor calibration, we can do this one of two ways. We can go right to the module, ACC13, and go to the special functions and perform the calibration that way. It'll work. It'll give you the steps. Or we can go right to the ADAS calibration function. Let's go do that. This next menu is specific to Volkswagen and Audis. It wants to determine the type of vehicle. And we have, it's an Audi Q5 chassis, year 2023. Hit start. All right, we have our menu over here. We can choose the ADAS system selection if we want to go to specifically to the module, and we could either read code, clear code, read data, stuff like that. Do the calibration directly from there. We can choose ADAS system scan, and this will do a scan of all the ADAS modules, give you a health report and what it can do. We have our ADAS calibration function, and this is where we'll go right to actually do the calibration that we want to do. And then you have a health report here. This will actually give you a health report of the vehicle. We're going to go right to the ADAS calibration function. Now you'll see what we want to do, again, is a front distance sensor calibration. They call that adaptive cruise control. So we're going to hit that. We have a choice for this vehicle. Has two different distance sensors on the front of it. Distance regulation 1 and distance regulation 2. Distance regulation 1 is on the right side of the vehicle. Distance regulation 2 is on the left side of the vehicle. Let's choose number 1. Now what this is doing is it's actually going to operate like the factory diagnostic tool, which is ADAS in this case. All right, and so you're going to run through the test plan just like you were running a factory tool, and it's telling you what you're going to do. What it's saying is, in these next steps, in this next program that you're going to run, you're going to have, it's going to check and read the DTC memory. If it notices that it's out of calibration, it'll give you that spec and it'll tell you which module, if any, is out of calibration. And then it also tells us to go forward. We want the key on, and we're going to set the calibration board up according to the manual, which we will get to. Continue. Again, this is what looking like the factory test plan. Just it wants to know where the test and adjustments as well, requirements needed, all the safety provisions. It wants to make sure you're doing everything safely, following the instructions, which we're doing. But yes. So when proceeding further, now we're actually going to get serious. All right. We want to make sure that we're following everything correctly. And again, when we get further into the test, all the instructions will be in here. Right now it's running through an automatic program, which it's going to read the codes in the cruise control module. So check module 1, now it's checking module number 2. Now what this is saying is it does not see a need for a calibration. We're going to do one anyway, just to show how that can be done. If it did see a need for calibration, this would show up here. It would show either module 1 and not module number 2. It's going to ask us what we want to do. Do we want to leave it alone? Do we want to find a TSV, or do we want to calibrate? I would love to I want to calibrate, so we're going to choose option number 1. So we're going to select the module to be adjusted. Control module for adaptive cruise control, J428. That's module number 1. That's on the right side of the vehicle. Control module number 2 is on the left side of the vehicle. We want to do the right side of the vehicle. This next menu will list the reasons of why you would need to do an ADAS calibration. If the radar sensor was loosened or replaced, if you loosened the bolt or moved it, you're going to need to calibrate it because it may not be pointing directly straight. If somebody loosened the bumper bracket or moved it, or somebody moved the sensor locating bracket, okay? Or what's most important to take note, if the geometry of the wheel suspension has changed, if you've done a major suspension alignment, or really any alignment, you should be doing the calibration on these cars. Or if the rear end, front of the vehicle was impacted by external forces after a collision. So our pre-calibration steps. Front wheels are in a straight ahead position, which they are. Axle geometry must be okay. That's a prerequisite for any ADAS calibration. You always want to make sure that the alignment has been performed, which we checked it before doing this. All doors must be closed. Tire pressures are normal, so you make sure the car is sitting nice and level. The key must be turned to the on position, and remove the air inlet grill or the radar sensor covers, which I have removed. To complete. Continue. Now, these are going to be the actual steps. So, it wants us to place a plumb bob at the center of the vehicle, in the front of the vehicle, and let it point naturally and hang to the ground. This point is point A. Place the 5 laser instrument at point A. At the center of the rear of the vehicle, let it hang naturally to the ground. This place is point B. Awesome. So let's do this. We're going to start by placing the 5-way laser. All right. What we're going to do now is take our plumb bob, which is included in the kit, and we're going to start measuring the center of the vehicle. Most vehicles out there will have an emblem in the front or some piece to measure the front of the vehicle. In this Audi, you're going to go right down the middle of this and drop your plumb bob right down to the center. We're also going to use one of these reflective pucks to drop it on, so we'll have a mark. So let's start that. So, drop our plumb bob down. We're centered. Exit. Touch. Right there. Awesome. That is our center point in the front. Okay, now we're going to measure the center line in the back of the vehicle. Much like the front, we're going to use the emblem. We're going to drop our plumb bob down onto our puck. Close. We're good. And centered. Now, we're going to use this reflector. We're going to place it right here on the X. All right, back at the front of the vehicle, we have a mark which we made before. We're going to use our 5-way laser, and we're going to place it on top of the mark. Turn it on. There's a laser underneath, a laser dot that points to the center. Line that up, make sure we're perfectly level, adjust if necessary. And then use our auxiliary mirror, place it down here so we look underneath the vehicle while we adjust it. Fine tune it with these little knobs on the side. Then we're good. And what you can also do here is press this V button right here, and that'll extend the line to the back of the car, or to the front of the car. All right, back to the scan tool. We set our lasers up. Next. Now what this is asking is to use the auxiliary mirror, which we did for the front of the vehicle. All right, fine tune the 5-line laser, which we did, and shoot the laser out the front, which is what we did. Let's go next. Now this is the important bit. It wants us to mark point C on the center of line point P. What it's asking us to do is it wants us to measure 1,280 millimeters from here to here. So let's get that done. Now what we're going to do is measure along our laser line we put on the front, 1,280 millimeters. We're going to take measure. Pull out the metric. Ready? We'll put this right on a red dot along our line. Make sure we're good. I'll take this reflective tab, 1,280, right there. Awesome. Move this out of the way. Good here. Now these next steps, we're going to do a little bit differently than what the instructions tell us here. So let's see what they're trying to tell us. All right. So what this is asking us to do is drop a plumb bob on the right front radar to mark where the center location of that is. All right. And then we'll want to use the ADAS mobile stand, which is the older version. Set that up with the front plate adapter. Set your cross laser back with your 1280 degrees. It wants to move that cross laser of the R2D2 back at that point of 1280 millimeters and shoot a laser across and then back down. What the 3-in-1 does is this takes all these steps out and makes it a 1, 2, 3 process. I'll show you how that gets done. Okay, to make this a little bit easier, what we're going to do is take our reflector from the back of the car, which we use to line up the front laser, and now that we know we have our 3 spots, back, front, and extended, we don't really need this in the back of the car anymore, but we can use this to line up our cross laser here. Let me show you. It's off. You always want to turn it off before you move it to lock pendulum in place. Put a reflective mirror, put on our X right here, and this guy back to here. Turn it on, Make sure our laser points down. Point to, let the point right there. We're gonna hit the V, bring a point back. We'll hit the V one more time, and it extends out. What that does is this is now the distance at which we're going to measure, we're going to calibrate the radar. It's doing the same thing that the instructors wanted to do with the ADAS mobile stand. And what we can do with the 3-in-1 is the 3-in-1 has lines across the plate that you can slide along the laser and you can line the target up. Let me show you. As long as I keep this laser in this target right here, this slot will match the distance of the plate. I'm level and I'm perpendicular to the car. I turn our laser on, then we're good to go. And again, you can see our laser coming across here. We're going to use this line right here, LAM0502, which responds to the plate. This is how far the plate will come out. So as long as we line our laser up, so it goes across that target, here and back, comes across it, we know we are straight and perpendicular to the car. Alright, now that we can get straight and perpendicular to the car, let's adjust our height and point right at the radar. Again, what I like to do is move this down low, put my plate on, and make my adjustments to make sure I'm level. Alright, when you're level, take this off so it's not so heavy. We turn our laser on here. Cool. Make sure this is good. Put this up. Now, you can slide laser over. Make it just perfect. Perfect. Now, right now, this car, because it's going all across, I know it's straight and perpendicular to the car. The laser is pointed directly at it, so I know we're pointing directly at it. Put the plate on, and we're set to go. All right, so what we did is a much more efficient, quicker way of getting to this point here. We used, this is for the ADAS mobile stand, we used the 3-in-1. We did all this already. Now we pointed at the car. The next step is the calibration. All right, we adjusted the height by using the laser pointed right at the target. Let's say calibration. All right, so it's going to make sure the adjustment device is no longer moved, which it's not. All right, make sure not to apply too much pressure on the AEC sensor while making the adjustments. This is going to be an adjustable sensor with a Torx bit. We'll go over that in a minute. We continue. So this front plate has 3 different positions. Position 1, which is 2 degrees forward. Position 2, which is straight up and down. Position 3, which is 2 inches back. We're going to start in position number 1. Let me position you and I'll show you. The tool is asking us to start in position number 1, so let's do that. Right now it's in position number 2, which is straight up and down. You can see the laser going straight down. Move it to position 1. We'll hit OK. It's going to do the adjustment in position 1. It's now going to ask us to turn it to position number 2. Position 2. You can see it asks to turn it to position number 2. Hit OK. Now it asks us to turn it in position number 3, so let's do that. Okay, hit OK. What this is doing now is reading if there's any adjustments that need to be made. And this one has a little bit of adjustment that needs to be done. It's asking us to adjust the upper left stud 3/4 of a degree to the left, or 3/4 of a turn to the left, and the lower right stud half a turn to the right. Let me set you up and I'll show you what that means. So when they're talking about studs, they're talking about this adjustment screw here and this adjustment screw here. So again, the measurements ask me to turn it to the left, 0.75 turns, which is 3/4 of a turn. So I'll use it like a clock. half, this 3/4, and then this one is to the right, half a turn. So, to the right, 1/2 of a turn. And now we do the calibration one more time. All right, now that we've made the adjustment, we're going to do the calibration one more time. That's after the adjustment. Says the adjustments were altered, which yes, they were. They're going to do it again. All right, we're going to run through the procedure one more time. We're going to skip past all this because we're all set up. Past this, the calibration. Okay, again, same setup as before. It asks us to put the plate in position number 1. So let's do that. It's already in number 1. Great. They tell us to put it in position number 2. Let's do that. Position 2. Okay. Asking us to put in position 3. Okay. Okay. Now if our calibrations are great, it'll go through. If not, we'll adjust it one more time. All right. That means we have a successful calibration. We're good to go. So, hey, please continue. It's going to check the memories, if any, and erase them. No more codes. Any codes that we have created have been erased. Alrighty. And if we want, you can adjust the other side if you want, or we can end the program. Right now, we're going to just end the program. End of test. And you can choose whether or not to save your ADAS report. I always choose to save them. Now from here, what I usually do is I email it to myself, or you can send it right to a customer, to yourself, or just save it. And that's it. That's how you do an ADAS calibration.